Hey, what's up, y'all? Welcome back. Your boy right here. Gonna switch and talk about the evens for a second, just because I feel like it. I want to draw your attention to a couple more of these key words. Number one, again, half. That means you gotta have a fraction. 15 more. The word more tells you that there's something already there. You have to actually put more into it. So that means you're adding something to, and then it says has 35. That's like the past tense form of is. That means we're talking about an equal sign leading up to the 35. Here we go. Jose is going to sell half of what he had and then buy 15 more, and he ends up with 35. I see something that says equals 35 to start. The 15 more part tells you that you need to have a plus 15. And the idea of half, and you're selling them, that's going to be a negative something over 2. Since you don't know what it is, that's where you put your x. Solve it. Easy. So since I said we're going to talk about the evens, that's what I'm going to do. Just hit you with number 6. So the next even number is 8. Let's talk about it. The sum of 3 consecutive odd numbers is 33. And I want to know what is the smallest of these 3 numbers. Okay, this is a tough one. The idea is this. The word consecutive, that is a key word all in its own. And when we talk about things that are consecutive, consecutive means back to back. Or plus one. So like 2002 and 2003 were consecutive years. They were back to back. 2002 plus one. That's how I got 2003. So if I talk about 3 numbers in a row, that means I'm having something like 2002, 2003, and now 2004. So for this situation, since I don't know what to start with, I should start off with an X. So the next consecutive number after that would be X plus 1. And the next consecutive number after that would be X plus 2. And we're saying that at the end of it, it has to equal 33. Easy enough. I would think so. We said sum, that means plus and plus. Here are my 3 numbers again. The x plus 1, and the x plus 2. The problem is, if I solve this thing out, I get an answer for x that is 10, which is impossible because I said they have to be odd. This question is really a really challenging thinking question because you have to think of how to make sure that you end up with an odd answer. We know that every even number can be divided by 2. And if you add 1 to an even, it becomes odd. So what I'm actually going to do is kind of change your thinking and put in, instead of just an x right here, what if I decided to make it 2x plus 1? That means no matter what, if I plug in any integer for x, I'm going to get an odd number out of it. So what would the next odd be? It'd be plus 3. And the next odd, so the consecutive odds this time, because I said it has to be odd, I'm using 1, 3, and 5. And that's what I'm really going to solve. When I get done with this problem, it's going to be the one that tells me what my actual value is supposed to be. The odd numbers that actually do work for this situation. Those numbers are 9, 11, and 13. And of course, you could have made a T-chart for this. You could have written out a whole bunch of information. You could have done this without an equation, but the whole purpose of what we're trying to accomplish in this video today, this word problem exploration, is how to set something up so that it's always the same, so that solving it becomes your least problematic part of this problem. Let's do number 9. Danielle spent $12 on a magazine and some erasers. That seems important. It says if the magazine costs $4 and each eraser costs $2, how many erasers did she buy? Interesting. I bought one magazine and a bunch of erasers. The erasers, it says each. The word each is a major key word. Word each is talking about something like rate of change. In other words, it's talking about a pattern that is based on multiplication. Always, always, always the word each is talking about multiplication. So here we go. 12 equals one magazine and a bunch of erasers. Easy to solve. So this stuff doesn't have to be very difficult as long as you know what to look for. It's all about these key words. Here we go. My man Jose, last time he was selling video games, this time he's renting a bike from Jenny. Cost $16 plus $4 per hour. That word per, automatically we're talking about something that deals with multiplication. Per and each really are the same thing. That's always going to be your slope. This should automatically alert you to y equals mx plus b because you saw per. He paid a total amount of money. It's $28. He said in this other part, 16 plus. Starting to see how easy can this thing really be. 16 plus $4 per hour equals $28. Easy peasy lemon squeezy. We set it up. Didn't even ask you to solve it. All I want to know is what should it look like? Number 11 is quite a doozy. It says there are 21 animals in the barn. Some of them are chickens and some of them are cows. There's 80 legs in all, and I want to know how many of each animal are there. So again, number one word that you see is each. That means there has to be some type of multiplication in here. But I need to stop you for a second. I want to talk about the fact that, again, just like in that proportion problem, there are two things working together. Number one is we need to talk about the amount versus their legs. I want to talk about a chicken compared to a cow. We're trying to add them all together. So peep game for a second. I don't know how many chickens there are. I don't know how many cows there are. But I know that when you combine them, you get 21. Since you don't know how many there are, what the actual amount is, you just put in a variable. And I don't want to use c's this time. I want to use an x and a y just because when you see what you actually set up in this problem, it's going to make a whole lot more sense. How many legs does a chicken have? For all of those who were just thinking 4, you're wrong. Chickens have 2 legs, but cows have 4. Unless you got some kind of weird situation happening on your farm. That's what I see. And in this particular situation, I have a particular method that we spent about 2 weeks dealing with. This part right here resembles a substitution question for me. I can just get one of the variables by itself, plug it in, and solve. So again, if I give you more than one item, you're probably going to have more than one equation. When I give you labels like animals versus legs, that's going to tell you that those are your two equations that you have to deal with. That's different. It's new. Good luck with number 12 because I just want to talk about number 13. My man Jacob bought 9 books for a total of $237. Seems too easy at that point. Math books cost $28 and English books cost $23. And I want to know how many types of each book did he buy. I said the word each so you know there's going to be multiplication involved. I gave you 2 types of book, English and math. So you know that there has to be 2 different equations. And I talked to you about the money and an amount. This is the amount. I'm going to call this value. Let's set it up. I should have an equation that talks about the amount versus the value. And I should have an equation that talks about math versus English and the totals. Because of this information, it actually starts to look a whole lot more like number 11 and number 12. The information is given to you. X plus Y equals 9. And now the value of each type of book, 28x, that's for the each, plus 23y, again, because it's each book, is going to be 237. Substitution type problem. Not a big deal now that you have it set up, of course. When it was just words, it was pretty much impossible for you to see the connection. Who cares about how many geese and cows are on a farm in number 12? I really care about you being able to set up the equation so that it's the same thing when you go to solve it. Last 2 problems. There's a class of 104 students that went on a field trip, and they took some 10 vehicles, cars versus buses. Wow. Sounds kind of similar again. Sounds like you should include cars versus one for buses. You should have an amount of cars and an amount of buses, and you should have a capacity in each one, or the value of each. A car is worth 3, a bus is worth 40, and there's 104 total students. I don't know how many of each there are yet, because all I know is the total has to be 10. Easy to solve. I mean, yeah, you're going to get some numbers, but the process is something that you know. And finally, let's talk about Jessica's Custom Kitchen Supplies. It takes them $1 to buy the supplies for a fork, $2 to buy the supplies to make a spoon. This store is selling forks for $6 and spoons for $4. It says last April, Jessica's Custom Kitchen Supplies spent $34 on materials, and they sold the finished products for $148. Do you have the right information? Yes, you do. I'm going to say that 1F plus 2S equals 34. That's my spending money. I'm going to say that 6F and 4S has to be the total amount of 148. That's my income. You can tell that I have F for fork, S for spoon, and again, there is a system of equations to solve. Good luck on the homework. Peace.